Welcome back from an ad break. So let's just quickly recap on what we did and what we focused on during this entire lesson. So we are looking at the change of state, whereby we're looking at what is the change of state and the factors affecting the change of state. We went on further to look at the processes of change of state, whereby we're looking at the freezing or solidifying versus melting, boiling versus condensation, evaporation versus boiling, and then lastly, we looked at the relationship between processes and the change of state, whereby now we're looking at the flow diagrams and the graphs that are explaining the change of state. We further on looked at these words, or used these words throughout this lesson, words such as melting, freezing or solidifying, evaporation, and also condensation. What's important for you to remember for this lesson and for the future is that particles are very small, and any small piece of matter has millions of particles. So if you just take one molecule of water or one drop of water from your glass of water, it has millions and millions of H2O particles within it. Also, particles do not expand or compress. The particles just simply move away or approach each other. So when we are adding energy into the substance, the particles are not going to expand or compress. They just simply move away or move towards each other. The speed of particles does not change if the temperature does not change. So if you don't add or remove energy, the particles will always be in the same constant motion. So their speed will not change. Particles do not melt, solidify, or change volume. So if you're looking at a water molecule, it doesn't melt, it doesn't solidify, it doesn't change its volume. It simply approaches the substance or move away from the other particle. That's the only thing that is happening. They do not melt, solidify, or change volume. Molecules do not boil or do not condense. So the molecules that we are talking about, they do not boil. The only thing that happens is that they gain energy from the surroundings and they start to move around more vigorously. So what you see is the particles moving around. What you perceive as boiling is basically the particles moving around more vigorously. They are not boiling. And what's also important to remember is that temperature is a measure of kinetic energy. And kinetic energy, it is that energy that a substance has when it is in motion. So if a substance is moving, it has kinetic energy. So I am going to leave you with this, which is a challenge for you. What would happen to gases if they were to be given more energy? We've seen what happens to liquids when you give them energy. What happens to liquids, to solids when you give them energy. Liquids, when you give them energy, they change states. But then what's going to happen to the last one, the gases? When we give them more energy, what's going to happen to them? I hope you're going to be able to answer this question. And I also hope that you've had much fun as I did. Until next time, bye.